So problem 3, we have Tarzan swinging on a rope swing. The length of the rope is 5 meters. So that's this. And his mass is 70 kilograms. If the tension in the rope cannot exceed 1,200 newtons, you need to find this stuff. Okay, so this is going to swing down. And so when this is vertical, right at this point, that's when my force diagram would look like this. So I will have gravitational force going down, but because it's traveling in a circle, my tension needs to be bigger. And I'm going to make it really obvious that this tension is bigger. Because when I do my net force equation, the sum of the forces in the y direction, remember when you're going in a circle, this has to be towards the center of the circle. So maybe I say towards the center. The center needs to be the positive direction. So in this case, it's Ft minus Fg. And because it's accelerating, because it's going in a circle, this will be equal to the mass times acceleration to go in a circle. And acceleration to go in a circle is v squared over r. And then this r is my 5 meters, because that's how long the string is. And so then I'm going to go, okay, well, my maximum tension is what they told me here. It cannot be more than 1,200. So that's going to go here for my tension. So that'll be 1,200. They told me my mass was 70. So that means my gravitational force is going to be 9.8 times 70. So we get 686. So it'll be minus 686. Okay, so then we get 514 is equal to 70A. Divide both sides by 70. And I get 7.34. And then B, we need to find the maximum velocity. So we're going to remember that acceleration to go in a circle is v squared over r. And we already have our acceleration here. So that's 7.34 is equal to our velocity squared divided by r. And our r is right here. It's this length of the string. So that's 5. And so I get v squared is 36.71. And then to find v, I need to square root that. And so I get 6.06 meters per second is my velocity.
Can you use that velocity in your mgh equals 1/2 mv squared? Because when I use that, I got a height that was like way too big.
Okay, let's do it. All right, so then for part C, we're trying to find the initial angle that the rope has with the vertical. And so we're going to use conservation of energy. And so we need to figure out what this change in height is so that we can find that angle. So that's H. We're going to also label this part Y. So now I need to use conservation of energy. Okay, so at the top, his kinetic energy is 0 because he's not moving. At the lowest point, he's going to have all gravitational potential, at the bottom, he's going to have all kinetic energy and no potential energy. And so my starting gravitational potential energy then plus 0 is going to equal my kinetic energy at the end plus 0. And so I can be like, hey, this is mgh, and that's going to be equal to 1/2 mv squared. I really do have plus zeros on both sides of this, but I'm not really going to care about that. Okay, so now what I'm going to do is take the velocity that I have and plug it in for this v. Yep, we'll cancel the m's. All right, and so now we have our height. And so now if I think about my pendulum again, All right, so now we need to find y so we can get that side of the triangle. So if we know h is 1.87, that's this. So then, and the whole length is going to be 5 because that's the length of the pendulum. So we'll have 5 is equal to y plus the 1.87. So y then is equal to 3.127. So then we can do trig to get the angle. All right, so then the inverse cosine of 3.12 divided by 5, and I get an angle of 51.29.